Hey guys, this is Sig. I hope you're doing well. I figured I'd do a little video today on context and golang. Because it won't be with that speed to do a video on context. I think context is a slightly strange concept in Go. They tend to be used a lot around API calls or anything sort of service related. And so people cannot cross them. I think, what is this context thing that I had to do it? So we're going to do a little short video going through some of the explanations of what contexts are, how we can use them, and how you can use them in your application code. So let's dive right into it. So let's bring up our trusty editor. And first thing, so you'll see the Golang infrastructure has a package called context, which is a first citizen package. And what it allows you to do is it allows you to create contexts. So there's lots of different ways for creating context, and we can see some of them here. You can see things like with value, with cancel, with timeout. And we'll go through some of these options. But first of all, what contexts actually are, right? So contexts are really sort of an environment that you're setting for your code or your code to execute in. So basically, we're creating some environment configuration, you might say, and setting some parameters for the environment that our code runs in. And what we can then do is we can actually use those parameters across our application to assert things about the environment. And this can be things like actual values that have been stored in the environment. We'll look at that in a second. But also things like timing, like setting deadlines, which is a common use case for context. Canceling context. If you have a long-running thing happening in another thread, and you want to sort of cancel it from the main thread, for example, and those are some of the things we'll look at. So first things first, one of the most simple things you can do with context is actually to use it to store values. So just like an environment variable, you can set variables in the context. You do this, for example, with the value function. And if you look at the function declaration over here, it says it takes a parent context, it takes a key of any, and it takes a val of any. So what does this mean? So a parent context, first of all, is it needs a context that this value is going to be stored against. And if you look at the existing available contexts, there are actually two that are primarily used. So one is to do. So if you look at to do, it's basically a non-nil empty context. So code should use context. To do is when it's unclear which context to use. So you see context.to do used a lot in tests, because you're basically saying, I just need an empty context. I don't really care a whole lot about where it sits in sort of the compilation time, what thread it runs in. I just need an empty context that I can pass into my function to get started with. So you'll see context.to do used a lot in tests, and that's probably where I used it as well. And another popular one is context background. So background is another empty context, but it's actually a more it's actually more of an initialization one, as it is here. So you'll see it says background returns a non-nil empty context. It never cancelled, has no values, and has no deadline. So it's almost like a background thread that just runs all the time, and you can use it to interact with the context. So those are the two that are primarily used. However, as we'll see in a second, you can also just trade a context. We can say context 1, for example, and then we can actually trade a context with cancel, for example. So if you say with cancel, what this will do is it will create a copy of the parent and return a cancel function. So let's maybe show some examples of how these different things work. So let's go ahead and use a context like to do, just because for this example. And we'll say, okay, we want to pass it a key for the value. So we'll just say my key, and then we'll pass it the value of hello YouTube, right? So what we're actually doing here, I could spell to do correctly, is we're creating a context. We are passing in B to do context. So we're saying this is just like a test context that we're playing around with. And then we're setting as a environment variable within that context, my key, and giving it the value of hello YouTube. Now, if we wanted to use this, we could actually go ahead and create a function that's call it do work with value, for example. And we'll say this will take as a parameter a context. And this is a common pattern you'll see in Golang. You'll see context passed usually as the first parameter in functions that require the context in some way. And this allows the context to have access to the underlying context that was passed in. So let's just say doing some work with value, and we'll pass in the actual value. And then we can say context of value, which is a function that allows you to return the associated value given a key. And we'll say, get the value in my key, and then we can just print the whole thing out. Could have just used, sorry, let me just get rid of this. We could have used printed in one line, but anyway, so now we have a function that uses the context, and now we can actually go ahead and call that function, and we'll say, do worker value, and we'll pass it in the context, and we create it. Okay, cool. Let's try running this. So let's try running that and see what happens. So it says, doing some worker value, hello YouTube. Okay, so where do they get hello YouTube one? Well, actually got it from the context, right? So we say, C takes value, my key. So we're accessing the key here. And the value is set here to be hello YouTube. And so that's how hello YouTube makes it into this string that was printed there. Now you might think, awesome, this way I can just spam a bunch of values into my context. I can just keep adding values to it. Because you could create another context in the same way and pass it the existing context as a parent, right? And then say my second key and say hello again, right? And this would work because now this context would have both these keys. The thing is, though, I would say be very wary of using the with value in context. There are times where it makes sense to use it, but most of the time in golang, I think it's an anti-pattern to use context values. There are exceptions for things like when you're passing forms. For example, if you're dealing with HTML forms, there are some examples where setting a context value does make sense. But most of the time, it's an anti-pattern because most of the time you want to just inject things as parameters and functions, and you want to inject things for dependency injection or one of the other good patterns for Go programming. Using context values quickly turns into anti-patterns like this, where you're basically using them as almost like global state and accessing them. There are exceptions. People yet like to, for example, if you're using logging or something, and rather than injecting the logger all the time, they might store a reference to the logger in the context and use that. Those things are okay, but again, use them with caution, right? That would be my advice. So this is one way of using context, is setting the values. But really where context shine, I think, is we're doing anything time related. You want to time box something. Let's, for example, look at doing some work, but we want to do it with a timeout, right? So we want to say, I want you to do some work, but I need you to do it within a certain amount of time. Otherwise, you need to crash out of it. And to set this up, let's do a couple of things. We'll give it a channel because we're gonna try to use some threading in this. We're gonna make a multi-threaded example here. If you haven't watched my video on Go routines and Go channels, I'll put a card at the top and go check that out. We're gonna use some of the same concepts in here. So let's pull in two things. Let's pull in a channel to work on and a wait group for us to tell the wait group when we've actually done some work. And then within this, we're just going to loop through, indefinitely we're going to loop through and do some work. And let's look at some interesting syntax around context. So context has a done function. You see this done returns a channel that's closed when work done on behalf of its context should be cancelled. Okay, so this is a really fundamental thing in channels is you can use a select statement and read values from the done channel of the context like so. And this will allow you to assert whether or not the context has been cancelled. So how do we do that? Let's just do a little example here. So we'll say, if there's an error in the context and cancelling the context actually counts as an error, we'll print out something went wrong. Let's try that. Something went wrong. And then we can print out the error that happened, right? Sorry, I need to do capital here. Error that happened. And then, just to be consistent, we'll actually decrement the wait group because we're saying, we tried to do this work, but it failed. If this case occurs, we can say what has happened then is that our worker, which is our little worker thing here, has actually finished. So go ahead and finish that like so. This is one of our cases, right? Now, the other case is that we actually do some work. So we'll have another case and we'll try to just grab some work from this channel. Let's see. So we actually said that this was an integer channel. It's fine. But let's do the work that we're doing. Very meaningful is just going to square an integer that came in. So we'll say we got an integer and then we'll square it, right? This is a very, very useful program. It just squares an integer. And if it does that successfully, then we call done, right? Like so. Okay. So let's look at what we have here. This is our little worker function. So what it does, right, is it repeatedly loops through and it goes through this select statement and then uses a special syntax around the context to go in and say if the context is done, so i.e. if the context is being cancelled by whoever owns the context, whoever has a reference to it, then I'm going to break out. I'm going to say, okay, something wrong. I must have run out of time or the context has gone away. Something's gone wrong. If not, we're just going to sit there and we're going to try to read an integer from the work channel, waiting for someone to give us work. And then we're going to do the work and then decrement the wait group. Okay, so let's set this up down here, right? So we'll keep this, but we'll say, let's start by creating our work channel. So this is, again, straightforward. We'll just create an integer channel. Let's just buffer it to a size 1. Why not? We'll only send one integer at a time. And now let's try this. So we'll say context2, and we'll say cancel as well. So we get a cancel function, which is another concept. And then we'll say context.with timeout. Okay, so with timeout is a very commonly used context. And we could do to do again. That's fine. We could have used background as well for this one, actually. And then we'll give it a duration. So let's just say we give it 3 seconds to time out, basically. So what this will do is it will create a context. And this context, after 3 seconds, will call its own cancel function, or will basically we'll call the done channel to say this context is done. You've had your 3 seconds, time's up. Sorry, guys. Which in turn, we should trigger this top part here. And until that happens, we can happily chip away at the work down here. So the other thing that we got, you see, is this cancel function. So let's look at with timeout. So with timeout, as you see, returns a context.cancel function. So the cancel function is a closer function, you might say, which is kind of the free up to any resources that relate to this context. So it's good practice to defer cancel when you're done with the context to basically free up resources that the context may have used, right? So let's set up some more things. Let's create a wait group. We need a wait group for this. So we'll create a wait group, just a standard one. And then we can say starting worker. Great. So we'll start the worker now. All good. And then inside a Go routine, we are going to call Go work with timeout. We're going to pass it our context2, the context that we just created for it to run under. And we're going to pass it our wait group. So what we should have now is we should have a thread that spins up. It has a context, which is this context2 that we passed in, which has a deadline of 3 seconds. It has a channel for it to listen to do work, and has a wait group that it uses to tell us when it has actually completed work. Now, the other thing we can do now is we can actually give it some work to do. So let's just quickly create some ints that we want squared. So we'll just say 2, 4, 6, 5. Doesn't really matter. We'll create some ints to keep it interesting, like so. And we'll start by giving it one int wait group. Also, we'll increment the wait group pointer with 1 to get started. And now what we can do is inside a routine, so that we don't block our main thread when we're enqueuing work, is we can actually go through these ints and we can say add one body of work to be done. And then we're actually going to send that integer on the work channel, right? And then to keep things interesting, let's just sleep for maybe 1 second. All right, let's sleep for 1 second here. And we'll say this is a function for it to run. So what we're doing here is we're going through these integers. So this is in the main thread, right? We've kicked off the worker thread with a timeout as 3 seconds. And then we're going to the main thread and we're saying, go ahead and create all this work. We could have done those things in reverse. That's how channels work, right? But for now we're spinning up the worker first, and then we're enqueuing the work. And then for each integer in this list, we're going through and we're saying add one body of work to be done in the wait group, so one thing to wait for, and send one of these integers on the work channel, which in turn should trigger our worker, and then just sleep for 1 second to simulate a bit of time. So at the end here, we can say worker that waits, because we want our main thread not just to exit and kill our program. We want it to actually wait for this work to finish or for something else to happen. Okay, let's try running this and see how far we get. Here we go. So it started squaring. I forgot a new line. And here we go. Things are going wrong, right? A couple of things went wrong. So there's the worker was happily going away. But what happened was you were squaring integers, all good, and then it said something went wrong. Context deadline exceeded. Okay, so what does that mean? So the context deadline exceeded is exactly what we expected to happen, which is that we set the context of the deadline of 3 seconds. We didn't complete the work within 3 seconds, and so bad things happened, right? Things went wrong. And in fact, we can try if we comment this out, and let's just add a new line here as well, so it's a bit easier to read. We can run it again. Here we go. It's working away. It's squaring integers. Cool. And now it goes completely crazy, right? Because now we're not breaking out of the work group anymore. So now it's constantly hitting this thing here, right? So there are a couple of ways we can fix this, by the way, but it's not really relevant to what we're trying to show here. What we're trying to show is that this is a way of using contexts to basically dictate how long some long-running operations can take to complete. And what you'll often see is you'll see this used for things like API calls, for HTTP calls, for anything that that you are worried will take too long or that might time out. For example, if you're doing an HTTP call, use a context of deadline so that you can say, I'll give you 30 seconds to complete this HTTP call. If it hasn't completed by 30 seconds, we need to throw an error. I mean, you can use this pattern up here to essentially wait for one of two things to happen. Either things go well and you handle it down here and you say, yeah, we're still doing work, all good, we're within the deadline. So this is kind of mimicking our API call. Or the context is being cancelled because something further up the chain has said, sorry, worker, you're taking too long. And so this is a common pattern that you'll see in Golang when you use contexts to do things like API calls. And if you use anything like gRPC in Golang, which is a common transport protocol or communication protocol that's used a lot in Golang, you'll see context used all the time, and especially context with timeout, because again, it gives you that I will give you X amount of seconds to do something, or, you'll crash and burn. And it gives you that kind of control from the main thread. Another quick shout out is the with deadline. So this, I don't think this one has too much use, but it is kind of interesting. So you can actually use the with deadline to literally create a deadline. So if you do want to use timeout, which most of the time you do, you want to say like, I'll give you 30 seconds. You could say like, I'll give you a deadline, and that deadline is tomorrow. Or you could say timeout date, and you could literally pass in, you have until tomorrow at 8 p.m. or this whole thing will self-destruct, right? Again, I've never used this in practice. I tend to use with timeout. Normally you want to give a kind of timeout, but that's another interesting use case for it. So I hope this was a little introduction to contexts and what they are. Again, remember that you'll often see context up to do using tests. You'll usually see context up background used in real applications and by the main thread. So if you're using the main thread and to control the context and create the context, which you normally are, you'll see things like context up background. And again, context with timeout, using the cancel function, using a timeout, and this pattern here of asserting whether or not a context has completed or not is a really common pattern in Golang. And I hope this video was useful to you. And if it was, do remember to like and subscribe, and I'll see you in the next one. Thanks, guys.